Hey guys, this is Mr. Gravakis. I'm going to be talking to you guys about section 3.5. I know we skipped a few sections, but the only other section that we really care about in chapter 3 at the moment. So we're going to be focusing on that, and that's specifically solving three variable systems. So we will have a few examples in here, and then you'll have a few homework questions to work on. So you guys will be able to solve a system of three variables using a sort of a combination of substitution and elimination. So as you see here, we have three equations. So just like in a two-variable system, which we've been working with the past couple of days, if we have two variables or two unknowns, we have two equations. So if we have three variables, then we have three equations. So as we're working through this, there's really no right or wrong way to approach this. I'm going to provide some guiding steps for you guys to work through, but basically it's try to keep yourself neat and organized as you're working through this, because it can get a little overwhelming organizational wise. So what I'm going to do is to keep myself organized is I'm going to label these equations as like equation number 1, equation number 2, and equation number 3. So I'll use these as a reference, okay? So as you're working through these, I'm going to start with substitution. So that means that I have to isolate one of my variables. So I'm going to work with the first equation, number 1, and I'm going to isolate x. So I'm going to subtract y and subtract 2z over to the other side. So when I do that, I'm going to get x equals 3 minus y minus 2z. Just for future reference, guys, when I work with z's, I actually cross them, because if you notice, my z's and my 2's super similar. So I cross my z's. So anytime you're unsure if it's a 2 or a z, I cross my z's. So if it's not crossed, it's probably a 2. So if we're trying to create steps for ourselves here, this would be what I would consider as a step 1. So if you're referencing your notes in the future for homework, classwork, tests, quizzes, anything like that, this would be step 1. So then what I would do next is I would plug this alternate version of number 1 into either number 1 or number 3. So this would be considered step 2. So step 2 would be to plug number 1 into, I'm going to pick number 2. You could plug number 1 into number 3 for step 2. It doesn't matter, but I'm going to do number 1 into number 2. All right, so what does this look like? So number 2 is 2. And then we solved for x, so we need to replace that. And then we have plus y plus 3z equals 7. So I'm going to underline this in green because I'm going to be plugging that into certain places. So just to color coordinate. So we're going to do 3 minus y minus 2z in here. From there, we're going to simplify this as much as we can. And then we have to move on to step number 3. So as you're working on simplifying this, you're not going to get an answer right away. We're just going to have a simplified equation. So we're going to distribute the 2. After we distribute the 2, we're going to get 6 minus 2y minus 4z plus y plus 3z is equal to 7. Combine like terms as much as you can. So in this case, we have 6. We have a negative 2y and a positive y, which means we have a negative y. We have a negative 4z and a positive 3z. So that means that we have a negative z equals 7. Subtract 6 on both sides. So that means that we're working with negative y minus z is equal to 1. We're going to note this as equation number 4 for reference. So the next thing that we're going to do is we are going to work on step 3. Step 3 consists of a repeat idea of plugging number 1 in, but we want to now plug in number 1 into number 3. So this is what it's going to look like when you plug in number 1 into number 3. We're going to distribute the negative. So we're going to get negative 3 plus y plus 2z minus 2y plus z is equal to 10. Again, we're at the same point. We're going to combine like terms like we did in step number 2. So we have a y and a negative 2y and a 2z and a z. So that means that we have a negative 3 minus y plus 3z is equal to 10. Add 3. Add 3. So that means that we get negative y plus 3z is equal to 13. So we're going to denote this as equation number 5. Step 4 is going to be that we are going to use equation number 4 and equation number 5 to solve for the variables. So in that case, we have y and z in equation number 4 and equation number 5. If you do not have the same variables in equation number 4 and equation number 5, you need that. So you need to go back and make sure that those two equations are dealing with the same variables, or else you're going to end up in a huge circle with this kind of problem where you continually plug stuff in or eliminate, and you're just going to go round and round. So make sure that number 4 and number 5 are working with the same variables. So now what I'm going to do is I can either multiply one of these by negative 1, or I can go ahead and subtract. either way, whichever one you're comfortable. So if I have negative y minus negative y, those will eliminate each other automatically. I have negative z minus 3z, which means I have negative 4z. And I have 1 minus 13, which gets me a negative 12. So then divide by 4, negative 4, divide by negative 4. So that means that we get z is equal to 3. So now that we found z, we actually want to plug z back into number 4 and number 5. So that's our next step. So when we do that, if we scroll back up, we have equation number 4. Seems easier to me. So we're going to do negative y minus, we're going to plug z in, equals 1. So z was 3. So we have negative y minus 3 equals 1. Add 3, add 3. We end up getting negative y equals 4. So again, if we divide by negative 1, we end up getting y is equal to 4. So then part of this step, you want to plug y and z into anything, but in particular for this case, you want to plug it into number 1. So we have number 1 is x plus y plus 2z equals 3. So I apologize, guys. I realized I made an error back here. This should be a negative 4, not a positive 4. So we need to change this inside here to be a negative. And then this situation down here is also negative. So instead of this being 10 and negative 7, we have a positive 2 and a 1. Okay, now that I've made my correction, final answer is 1, comma, negative 4, comma, 3. All right, so I went through this one pretty slow just so that you were able to see each step and what I was doing for each step. So just to recap, first we isolated in step 1. Then we plugged what we isolated in to number 2 for step 2 and number 3 for step 3. From those 2 steps, we got 2 new equations, number 4 and number 5, where we used our knowledge of systems with 2 variables to solve for z, which then allowed us to find y, which then allowed us to find x. And then we stated our final answer as an ordered triple.